Good morning, ladies and gentlemen. My name's Andy. Work closely with Lisa in setting up these trainings. Juan will be presenting momentarily. Let's just give it a minute or so for people to come in, and I'll let Juan take it over. While we're waiting on that minute, encompass.com is where all of our training stuff's at. There's also a link to the GE site there for their on-demand training. And we had one of these this morning, a really good presentation from one, and I think you guys are folks get a lot out of it. Juan, why don't you, to respect their time, why don't you go ahead and let's get rolling.
Yeah, definitely. So thank you everybody for joining. Thank you for joining on time. There may be a couple of you that we had a session this morning earlier, and I know some folks joined a little bit late, but lots of good material today to cover. And first, I'll start by introducing myself. So thanks everyone for joining. My name is Juan Morales. I'm the Senior Staff Field Application Engineer for Smart HQ Pro here at GE Appliances. And we're actually in our brand new studio here, all set up with a nice microphone, as Andy was saying. And we're excited today to bring to you knowledge about how to interpret schematic diagrams. In particular, we're going to focus on front load washing machines. Of course, this is not going to be the only training session we're going to conduct with diagrams. We're going to also do some more in the next month on dishwasher. Then we're going to move to refrigeration and other products as well. But today's session is going to be solely focused on the front load washer because we understand it does bring a bit of heartache to technicians when they're trying to troubleshoot things like a washing machine not spinning, not draining, things of that nature. So we're going to cover that all in detail. Now, schematic diagrams, my friends, you can find them typically at the where the with the product itself. So if you ever service a GE product, if you take off one of the covers, there's typically a tech sheet inside that's called a mini manual, and that's going to have the schematic diagram. Unfortunately, for some of us that have been doing this for quite a while, when you walk into the customer's house and you look for that tech sheet, it no longer is there, right? And there could be a couple of reasons for that. Either the installers, maybe they thought it was just an extra piece of paper that was garbage and they tore it off and threw it out, or maybe a technician was there prior to you and they thought it was a nice souvenir and they walked away with it. Either way, if it's missing, you will have to get it someplace. And the best place to get it, my friends, is going to be through the Smart HQ service application, which is going to be another topic we're going to cover today briefly. So I just want to go ahead and share my Smart HQ service screen over here with everybody. I already have it for time purposes opened up, but this application is going to give you access to all the training and service documentation that you need. So if we click manuals and bulletins, this will bring up this manual and bulletin menu. And if you just select the mini manual, here is where you'll find the latest and greatest revision of that text sheet, the mini manual. And here's where you're going to find your schematic diagrams. And I'm doing this on an iPad, so if you pinch to zoom, whether it's a phone, iPad, whatever the case may be, take a look at the crystal clear quality of the graphics here that you'll find. Lots of really good information. And again, this is all available to you right from the Smart HQ service application. So I just wanted to share quickly where you can find all this great information, my friends. Now, with that said, what I want to talk about is also, if you want to get this application or this tool rather, Encompass is running a really good promotion, actually probably the best promotion we've ever seen here, where you can purchase the Smart HQ service module and you're going to get a free month subscription to the service. This is going to cost you upfront $199, but if you purchase $2,500 worth of GE appliance parts from Encompass over the next 2 months from your data purchase, you will be receiving a $200 credit. That means you essentially are getting this tool for free, no cost to you whatsoever. If you want in that month to download every single mini manual for every product you can and save it to your computer, save it to your phone, you can. And then you have all the information. But besides all that, there's a lot more you can do. Again, today's training is going to be focused mostly on schematics. But if you are interested in getting this product, simply scan that QR code. Take advantage of it because not many folks are going to give you something for free like that, and essentially Encompass is doing just that, right? You buy it, spend the parts purchases, and then you get that $200 credit. All right. So with that said, my friends, let's go ahead and get started. Schematic diagrams. So if you've ever tried troubleshooting a product without actually diagnosing it, uh, the service call can go one of two ways, right? You can either shotgun the repair and just throw in a part and get it right the first time, which is great, or you can put in a part, it doesn't fix it, you try another, that doesn't fix it. Maybe you try replacing both parts and finally you get it to work, but by the time you're done with this, you've spent a lot of money, time, resources. So this is something obviously we want to avoid from happening. And the best way to do this is to diagnose properly, and it truly all starts with understanding the schematic diagrams. So some of the benefits, again, are accurate diagnostics. This allows you to pinpoint the root cause of the failure. Also, it allows you to get the parts right the first time, right? Because if you know exactly what is causing the issue, and it doesn't matter whether it's a washer, dryer, fridge, if you know what's causing it, you can replace the part that you need right away. Also, safety, right? Safe service practices. Anytime that you walk into any, live circuitry, there's a potential for getting shocked, even electrocuted, or potentially damaging the equipment. So to prevent you from doing that, if you look at the schematic diagrams, there's going to be information in there that's going to tell you which circuits are live, which circuits are safe to use with a multimeter, which are not, and lots of information there that prevents you from hurting yourself or again damaging the product, which we don't ever want to do. And of course, reading schematic diagrams promotes consistent workflow. Okay, this allows you to establish a standard repair practice, and this could mean something as simple as maybe, the first thing you do is, let's say a washing machine is dead, you check the AC outlet for voltage. That's what I used to do, right? I established a procedure where my first checkpoint was the most basic things. Are you getting voltage out of the outlet? If not, then there's probably something wrong with the outlet and nothing wrong with the appliance. And then you take it from there. But this allows you to have consistency with your work. And anytime you have consistency on anything, you know this already, you're going to be much better at it in the long run. So that's why it's important to understand how to interpret these schematics. And today I'm here to show you exactly how to do just that. So with that said, we're going to start with AC and DC circuits. But before I do that, I just want to tell everybody that's on the call here that this is going to be an open conversation. Okay, we're going to go back and forth here. I want to learn from you as much as hopefully you will learn from me. So if you have any questions, comments, concerns, feel free to chime in, drop a note in the chat, or just raise your hand. Andy will notify me that there's a question, and I will pause periodically to answer any question that you might have. Okay, but we want to make sure everybody understands this material thoroughly. So starting off with AC versus DC circuits, okay? AC basically stands for alternating current, and alternating current typically comes from your wall outlet, and it's 120 volts AC. Now, if we get into things like an electric dryer or an electric wall oven, of course, those are going to be higher voltage, 220, but for the purpose of this class, we're going to deal strictly with 120 AC, because that is all the voltage that is required to operate the washing machine. Now, this AC is typically used to power high power loads. So again, one example of AC would be the power coming in from the outlet right into your main control board, right into the machine. Other examples are your water valves, right? Your water valves have they're solenoids which drive on 120 volts AC. And then other examples are like your heater, your drain pump, things of that nature. So those would be a couple examples of AC circuits. Again, you have to be careful because if you touch the AC, it is going to shock you pretty good, and it's going to hurt. So you want to make sure that you're always careful with that. Now, direct current is a little bit different, right? That's DC, and that voltage is much lower. It's typically somewhere between 3 and 24 volts. But the advantage here is that 3 to 24 volts is not really going to hurt that much if you touch it. The only thing is that you have to be very careful with your multimeter, because if you short out any of those components, you could potentially damage the components, which is not good. So a couple examples here. Your thermistor, right? So your thermistor is actually a DC driven circuit, And another example would be a communication device such as a pressure sensor. Now, a pressure sensor is going to measure how much water is in the washing machine, right in the tub. And let me go ahead and zoom in over here to kind of give you a little bit of an example of why reading schematics is important for safety purposes. So nice and close over here. So if you take a look at the pressure sensor, you notice that it's got a an indication at the bottom, right? It's got a note that says to measure output voltage, connect your probes between pins 4 and 3, which is great. This is a great piece of information. This allows you to know what voltage is coming out of the pressure sensor. And based on a table that is on the mini manual, you'll know if there's water in the tub or if there isn't, or if there's a problem with the pressure sensor, and in which case you would need to replace the main board. But it's also giving you some very important safety information, which is saying shorting pins 3 to 2 will cause the main board to shut down. Now, I don't know if this means the main board may shut down temporarily for a couple minutes, for 10 minutes, or if it is going to get fried permanently. Either way, I do not want to find out the hard way. So I am not going to short out those two pins because now I know this great information. It's details like this that are in the schematic diagram and the tech sheet that are going to make a difference, because the last thing you want to do is you go in there, you think you're doing a good thing by troubleshooting, you touch two things that are going to zap the board and it's fried, and now you have to go, order a board, have to schedule another service call. It becomes a mess. So the more you pay attention to these details, the better it is going to be in the long run. Okay, my friends, I'm going to take a minute just to shut off this. So I'm going to leave you with this graphic. I'm going to shut off a little space heater that I have behind me. There we go. It's making a little bit of noise because it is a chilly morning here in northern New Jersey. It's about, I don't know, 20 degrees outside. It's not as warm as it is in other parts of the country. So, all right, now that we got that out of the way, let's go back over here to business. So the other thing that we need to understand, my friends, is on the schematic diagram, we do a really good job with our schematics at placing the boards, right on the schematic. So let's identify some of the boards that you're going to actually have to go to, like once you interpret, what circuits you want to measure. So let's take a look at that. The first one, obviously, it's going to be the main control board. So that whole square right there, if I take it out, you see that whole box. That's your main control board, right? And that, of course, is what drives the major components. Then you have the inverter board. So the inverter board is what's going to drive the motor. And of course, we can't forget about our user interface, which brings in from the outside world, right, from the users that actually control the machine, it brings all those commands back to the main control board. Now, at a very high level, because we're going to get into more detail later on, at a very high level, let me give you some information about these boards. So I mentioned the main control board is responsible for controlling the components like your drain pump, water valves, all your DC sensors, things like that, right? But it also has a very important function, and that is to supply 120 volts AC to the inverter. The reason I'm saying this, or I'm emphasizing this, is because we constantly get phone calls to our tech support line saying, if a washing machine is not spinning or not agitating, they change they change the motor. Right? That's usually the first thing they change. They swapped out the inverter, still not working. And then they try swapping them out again, and it's still not working. And the reason could be that there's no voltage coming from the main to the inverter. So that's why it's important that we highlight this information early, because later on we're going to go into detail where exactly you could put your multimeter based on the schematic to determine if you have that voltage going there or not. All right. So I just wanted to kind of throw that out there to preface the rest of the this training. Now, the inverter board is going to drive the motor using that AC that it takes from the main, but it's going to convert it somewhere inside the magic of the inverter board. It's going to convert that AC into DC signals that are going to actually drive the motor. Again, we'll get into the details of that later on. And as I mentioned earlier, the user interface provides the touch commands, but it also receives 13.5 volts DC from the main, which is very important because if you ever come across a situation where your user interface is dead and you already checked the AC outlet in the wall, it's good. You might think, well, let me swap out the user interface and see what happens. And That may work if the user interface is bad, but what if the user interface is good and the only problem is no voltage from the main? Again, you would be just swapping out parts for no reason. So today we're going to show you how to determine exactly where to measure, how much to measure, how to do it carefully, properly, so that you can identify exactly what's causing those problems. All right. So let me go ahead and switch slides over here. Beautiful. Okay. So now what we're showing here is a close-up view of a main control board without anything attached to it. And the reason why I want to show you this is because the first thing I want to do is kind of identify your connectors, right? So on the schematic diagram, there is going to be a set of boxes that say J512, J506. Anything with a J means it's a connector. But to identify what it actually looks like on the board, you have to actually know what it looks like on the board. Okay, so we're going to kind of start with the AC connectors. So any connector that you see there that I've highlighted in red. So J101. So let me zoom in over here. So like J101 is your AC input. J513 is your door lock. 514, I think it's your water valves. You notice these connectors have kind of pretty large spades here, pretty large pins, right? Because they do drive higher voltage loads. So obviously we want to have good coverage there for electric current. Now, the ones that are labeled in blue here are your DC connectors. And these are, of course, going to be a bit smaller in terms of the pin size, and they're going to have more pins because, again, smaller profile for the wires. And we cannot forget this bad boy over here. That's our pressure sensor. That is the sensor that is going to detect how much water is in the washing machine, and it's directly attached to the main. So if that thing goes bad, you would have to replace the main control board. So we're going to start off very easy, baby steps here, nothing crazy. We're going to start off with two connectors. And the reason why I'm picking connector J512 and 514 is because these connectors are going to power your drain pump. So 512 is for your drain, and 514 is for your water valves. All right. So with that said, let's go ahead and switch to a close-up view of a section of the schematic diagram that focuses on the two connectors as I spoke about, J512 and 514. And again, these are the ones that drive your drain pump and your water valves. Now, one thing, my friends, on your schematic diagram, there's not going to be a nice, beautiful picture of the drain pump and the water valves like you see there. That's only for us in this presentation to highlight what it looks like. In your world, you're simply going to have a bunch of lines and boxes. That's going to, like that little box that says drain pump, that represents your drain pump with two pins, 1 and 2. But let's focus on the main control board connectors. So let's zoom in right over here. And if you notice, the schematic symbol for a connector is simply a box with a bunch of numbers. So connector J512 is a box with 6 numbers, 1 through 6. So that means it is a 6-pin connector. And the reason why only pins 2, 3, and 5 are labeled is because these are the only uh, pins in that connector that actually have wires going to it. You will see, it doesn't matter which brand appliance you work on, you'll see multiple connectors that either have the entire connector filled with wires, or it might just have 1 or 2. So don't be alarmed by that. It's quite normal. Now, in this case, if we zoom out here, we notice that the pins number 2 and 3 go directly to the drain pump. And one very important thing that I want to talk about as well, my friends, so let's zoom in over here. A lot of people ask me, okay, so I'm at the connector, I'm at the board, right? How do I identify which one is pin 1 and which one is pin 6? So very easy. Pretty much every connector on any board, it doesn't matter, again, the manufacturer, will have a little triangle either on one end, right, which identifies pin 1. So in this case, it's easy to know that pin 1 is going to be empty, pin 2 is going to have your line signal going to the drain pump, and pin 3 is going to be your neutral. So that's what allows us to identify where to place our multimeter leads when we're actually doing it in real time, right, at the point of the machine. Now, the other thing is your wires are labeled, right, with a letter and a number. Now, the letter is going to be the color, and the number is going to be the wire gauge. So if you look at, for example, pin number 2 on connector J512, it says C20, C, if we look at the table, is actually brown. So once we're looking at a brown cable, or once we see a C, we know it's a brown cable. And of course, B, which is your neutral, if you look at the table, that's black. So what I'm looking for is going to be a brown and a black wire coming from that connector going to my drain pump. And this is extremely important because if I actually want to measure at the board, right, not at the drain pump, because it's hard to get to the drain pump, but it's easier to get to the board. If I want to measure voltage from the main board to the drain pump, all I have to do is go ahead and put my multimeter leads on pins 2 and 3, which now you see what it really looks like on, in your world, right? On the machine. It's going to be attached. It's going to be dusty. It's going to have all kinds of stuff going on there, but you can clearly see that pin number 2 is the brown wire. Pin number 3 is the black wire, and that's where you would put your multimeter leads to measure 120 volts AC if you activate the drain pump. So this is an easy way to troubleshoot the board for voltage going to the drain pump. Um, Very important, my friends. I want to emphasize something. When you're troubleshooting, for example, a no draining condition, no spin, the water valves aren't bringing in water, right? You can test at the component or you can check at the main control board. But what's nice about testing at the component, sorry, at the main board, is that you're checking directly at the source of voltage, which is the main. And also, if you disconnect that wire harness from the connector, you can use those same pins to measure the resistance of the component. And not only are you checking the resistance of the component, but also the wire harness. And I'll show you how to do that in a minute when we go into resistance checks. But this makes it very easy for you to troubleshoot from the control board rather than do heavy duty disassembly of the product. It saves you time and it just easier on overall on your back too. All right, with that said, let me go ahead and switch over to the water valves. Okay, so that's the section for the water valves. And again, we're going to zoom in here just to get a closer view. A little too much. But there are my water valves right there. So my water valves are connected to J514. And if we look at the connector, it's a 6-pin connector, right? With only pins 1, 2, 3, 4, and 5 utilized. Pin number 6 it appears to be empty there. Now, again, looking at the color of the wires, because a lot of the times the easiest way for you to check is if you start to sort of become familiar with these color wires. So if we want to look, for example, at our bleach valve, just the bleach as an example, we see that there's an N. And if we look at the pre-wash, we see that there's a Y. Now, what does that mean? So an N, if we look at the table over to the left, N stands for blue. I believe it means navy blue. And the Y is pretty easy to guess. It's yellow. Now, the valve line over here, so let's zoom in again. The valve line, so we're actually applying line voltage to every single water valve, says C20. So that is going to be a brown wire. We saw that earlier with the drain pump. C is brown. And that brown line gets split up into 4 directions and it goes to your hot, your cold, your bleach, and your pre-wash valves. Now, on the other side of the valves, there's going to be a complementing neutral line, which engages every time you activate each valve individually. And of course, if we look at the N, that is going to be a blue line. And if we look at the Y, it's going to be a yellow line. So your bleach and your pre-wash would be blue and yellow wires. Of course, it's easy to guess for pin number 2. It's got a W, that will be for white. And pin number 3, it's R for red. And if we sort of zoom out over here, in your world, what this is going to look like is just like that. So there's your connector, right, for the water valves. As you can see, uh, they're in pretty good order there. The brown at the top, then it's white, red, blue, yellow. And let's just say, hypothetically speaking, that I wanted to measure voltage for the let's say for the pre-wash valve. I would put one lead on the brown cable and one lead on the yellow. I would activate my pre-wash valve, and that would allow me to see 120 volts AC coming from the main to the water valves. So that's how we would identify that particular voltage. So while we're on this topic, my friends, just want to pause for a second briefly and open it up to see if there's any questions on the line.
Just unmute your mic, speak openly. You're among friends.
Yes, don't be shy. This is the time to ask. And if there's no questions, I'm going to assume that you're understanding everything. So I just want to make sure if there's questions, we clarify anything. All right, we will pause again for questions in a minute, but let's go ahead and move on to DC signal path and color. So DC circuits. Okay, now DC circuits, as I mentioned before, it's low voltage, but these DC lines are important because we'll start with the user interface board, right? So the communication between your main board and your user interface is extremely important because if there's no communication there, guess what? You have no operation of the product at all. So to better see that, we're going to go ahead and look at that section of the schematic diagram. And again, we've taken just a small chunk and zoomed in on it. So connector 615 over to the left, that is the connector on the main control board, and connector 101 on the right, that is the connector on the user interface board. There is a wire harness that connects them both. And as we can see, just in the interest of thoroughness, let's talk about the connector. So J615 is a 9-pin connector with 4 wires attached to it, right? Pin number 2, 3, 4, and 8. And of course, J101 on the user interface is a 5-pin connector with 4 wires attached to it. The one that I want to place emphasis on, and I think it's pretty obvious there, is the one that carries the 13.5 volts. And that is going to be a black wire because we already saw the color code, right? B22. So in this case, the 22 is the gauge. And because the number is a little bit bigger than 20, that means the wire is a little bit skinnier. The higher the number, the skinnier the wire. And it makes sense, right? Because skinny wires carry lower voltage. Thicker wires will carry more current, more voltage. So that's why DC circuits have skinnier wires. AC circuits have a little bit thicker wires. Now, that's your 13.5 volts DC. Where's your ground? Your ground is on pin number 4 if you're looking at the main control board, which is a red wire, which is kind of weird, right? Because typically red is voltage and black is ground, but I guess in this particular case, this is how it's set up. And if you go to the machine, it's precisely like that. Either way, it doesn't really matter whether you put your multimeter or leads one way or another. You're going to get either positive 13.5 or negative 13.5. As long as you see 13.5 on your meter and make sure you set it to DC, you should be good to go. Again, very important, my friends. If you have a dead user interface, measure voltage from the main to the UI. Make sure you have 13 volts. Measure it also at the user interface. Make sure you have 13.5 volts there. And if it's missing on either end, check the continuity of the wire harness. If you from one end to the other, if there's no beep, it's possible it's your wire harness. Okay, but again, typically if there's voltage coming out of the main, the problem is going to be the user interface. No voltage from the main, 100%. You got to replace the main board. That would be the fix for that. And again, if you use the schematic to guide you, you can't go wrong. So with that, we're going to switch over to the inverter board and let's take a look at the communication between the main and inverter. So we're going to zoom in over here. So we have 2 connectors, one at the main, which is J601, and one at the inverter, which is J301. Now, the important cables that we're concerned with that we can actually measure with our meter are going to be your 5 volts. So that's pin number 1. That's a red wire. So in this case, actually, for voltage, they use the red. And obviously your complementing ground is going to be this black wire over here on pin number 4. And if you follow the line, it says ground. Now, you can measure this very easily, okay? You put your meter to DC, you place the leads between pins 1 and 4 on either connector, it doesn't matter, and voila, you get your 5 volts. But there's another very important voltage that comes from the inverter board back to the main, and that is your speed feedback. That is a voltage you cannot measure with a meter. Okay, unfortunately, there's just no way because it's not going to give you anything consistent. It's going to give you something, but it's just going to be jumping around. The numbers are just going to be jumping on your meter, so there's no way for you to determine. And the reason why this signal, it's not really a voltage, it's a signal. It's very important is because If that signal is not present, guess what? Your motor is not going to spin. It's not going to agitate because the main board needs to receive that feedback from the inverter to know that the motor is either spinning, it's stuck, it's agitating, or it's going out of control, something like that. That is very important. Now, that signal, the speed signal, originates from the hall sensor on the motor, goes to the inverter, and then back to the main board. And we're going to show you a little bit later on the easiest way to actually be able to measure that is not with a meter, but actually using Smart HQ service. We'll get to that at the end, but I want to make sure I cover the schematics thoroughly so you have a good understanding, a good foundation of how you can troubleshoot these kind of complex circuits. All right, so with that said, now we're going to get into resistance checks, okay? Because every single component, it doesn't matter whether it's a drain pump, water valve, motor, heater, it has a resistance associated with it. And if you can measure that resistance accurately and it's good and it's still the component's not working, it could be that there's no voltage coming from the main. So at least you rule that part out. And that's very important because again, we don't want to be part swappers or we don't want to just throw every part in there. We want to know exactly which part we need so that we can get a first time fix for the majority of the time. Okay. So let's go ahead and take a look at some major components you're familiar with. And those are your motor, your drain pump, and again, your water valves. Very, very easy to follow. So on the diagram itself, if you look at the upper right-hand corner, there's a box, there's a table, and we're going to zoom into it. That is your resistance table. So looking at it, you can clearly see that the resistance table gives you, what does it say for the drive motor? 3.5 ohms plus or minus 7% phase to phase. So that would be between your three connectors, you should have about 3.5 ohms. If we look at the water valve right below, 1070 ohms on the coils. So if you place your meter leads along across the solenoid, you should get about 1070 ohms. And of course, your drain pump is about 19.5 ohms, plus or minus 10%. So if we go ahead and take a look at let's start with the motor. Okay, if I want to measure at the motor, what I would have to do, if I can get to the motor, I would go between the red, white, and blue wires there and just measure any two combinations. And according to this table, I should get about 3.5 ohms. Now, if I want to look at so let's zoom out over here. If I want to look at the drain pump, I would have to go across those two like holes at the top there. That would give me my 19 ohms. And of course, if I want to look at the water valves, I would just go across any of these two spades over here, and I should get about 1070 ohms. But that's not always going to be the case, my friends. You're not always going to have the luxury of being able to measure at the component. Especially think about it, right? If I want to measure resistance at let's start with the drain pump. I have to somehow get to the drain pump, either remove the front cover of the washer, lift it up, whatever the case may be. Very difficult. But if I go to the main control board, I can actually use the connector, detach it from the board, and measure resistance right there. So let me show you how that's done. So let's start with the inverter board connector, which is your motor. And if I detach the connector, the motor connector from the inverter, I can measure between the blue and white, blue, red, or white and red wires, and I should get that 3.5 ohms we talked about earlier. If I want to measure the drain pump, all right, so let's kind of zoom out over here. There's my connector for the drain pump, okay? I would literally have to detach the connector from the board, place my multi-liter leads on pin 2 and 3. We saw that before on the schematic, and I would get my 19.5 ohms. What's really nice about this is that I am not having to go to the drain pump, so it's very easy. I'm right at the top of the machine, right where the board is. Just detach the connector, put your leads, and I can see if my resistance is good on the drain pump. Obviously, if the drain pump is shorted or open, that's clear indication I have to replace the drain pump. This also tells you if the wire harness from the component to the main is intact. So if I get my resistance good there, then the wire harness is also good, which is really nice. Another thing, my friends, if you notice this, very important when you're measuring resistance, always detach the connector from the board. And I'll show you that as well with the water valves over here. So here are my water valves. And again, if we look at the connector itself for the water valves, you notice we've detached the connector from the board and we're measuring across pins 1 and 5, which is going to give me about 1,070 ohms, right? Go into the water valves. It's very, very important that you detach the connector. So two things I want you to remember when measuring resistance. Number one, unplug the appliance from the outlet. Unplug it because if that uh, connector is live with AC and you try to measure resistance, you're going to blow your meter. Number one. You might even see a spark and maybe some smoke come out. We don't want that. But number two, if you, even if you don't damage anything, if you leave the connector inserted on the board and you try to measure resistance like that, you're going to get board resistance. So you might get an erroneous value. And you might think, well, uh, it's got to be a bad component because the resistance is bad. I'll give you an example. Remember we said the drain pump is about 19 and a half ohms. So I had a technician call me once and said, "Hey Juan, how do I troubleshoot if a drain pump's good?" So I said, measure the resistance from the board, from the connector on the board, not from the board, from the connector on the board. So he was telling me, yeah, I'm measuring like 1,000 ohms, something like that. I'm like, impossible. The drain pump is not that high. It's much lower resistance. He's like, no, I'm at the right pins. I'm measuring close to 1,000 ohms. What's going on? So then I remembered, did you detach the connector? He's like, no, the connector's attached. Once he detached it, then we measured. It was about 19 ohms. Okay, your drain pump's good. It's got to be a board or something else. So that's why it's important that you detach the connector, just like we have in the pictures over here, so that you don't run into that same issue. Okay. Um, so with that said, we have now come to sort of the um, we're heading toward the end, right? This is where we're going to come full circle. So everything I just showed you right now, everything I just explained, voltage checks, following the lines, resistance checks. Okay, now we're gonna come full circle and put it all together to troubleshoot a washing machine that is either not spinning or not agitating. So with that, let's go ahead and take a look at this diagram over here. But before I do that, I want to open it up to see if there's any questions on the line. All right. So let's go ahead and move on. So again, as I mentioned before, my friends, there are going to be some major components that are going to be responsible for either spinning or agitating the basket, right? And those components
Yeah.
are. Oh, had a question there. Somebody chimed in.
Yes, sorry about that.
Yeah.
Good morning. My name is
Good.
Jose Rodriguez,
Good morning,
and
Jose. Thanks
I
for
actually
joining.
have two questions. Good,
Yeah.
good. How about yourself?
Good. Good. Thanks.
Okay, so my question is, on the 13 DC voltage supplying the interface board, are you gonna get that voltage with the unit, um, as soon as it's plugged in and the main board?
That's a good question. Yes, actually, yes, you would have that voltage because um, that's a great question. So the user interface, right? It's a living,
Mhm.
breathing board that is constantly waiting for the user to touch the button to actually activate it. So in order for it to be living and breathing, it's got to constantly be receiving that voltage. That's a great, great question, and I'm glad you asked. So as soon as you plug in the washing machine to the outlet, the board will begin to supply the voltage, the 13.5 volts DC to the main board is going to supply the 13.5 volts DC to the user interface. That is correct. Yes.
Okay, awesome. And then my other question will be for the harness on of the drain pump, the
hmm
J512.
hmm
What's the pin number five? It says what was pin
Oh,
number five for
yeah,
the
pin number
pin?
5. So we actually have it. Let me go ahead. I have actually. So pin number 5. That's another great question as well. So this is okay. So here's another. So you could kind of see it right here. That's 512. So pin number 5 is the detection circuit for it goes. You know what? I don't have the full schematic for that, but it has absolutely nothing to do with the drain pump. It's for another a higher end model that has other components, other features on it. And I guess I could. I could try to find it. You know what? That's a good question. Let's go ahead and switch gears over here because I'm glad that you're asking this. I'm going to go right to the Smart HQ service app, and we're going to go to the mini manual here, and we are going to look at that circuit. That's a great question. So the one we were looking at was this model right here. Okay, beautiful. Okay, you could see right there 512, even though it's flipped to the side, right? So pin number 5, detection B22. If we follow it, that goes to the harness. Oh, that's a vent damper. Okay. So what that is, my friend, I'm glad you asked. That is a these machines, these front load washers. The big problem with front load washers is if you close the door after a wash cycle, it's going to get all moldy and smelly and stinky, and it's really terrible. So GE Appliances allows you for the first time to be able to shut the front door after you're done with the cycle, and that vent damper that I talked about right there. So that's a mechanism that's going to open up. The motor is going to begin to run, so it's going to create almost like a vortex of air, and it's going to air out all the smell, all the moisture inside of the machine, so that it doesn't build up any odors or mold or anything like that. And if we follow again that line, it's basically going to that vent damper to ensure that it's detecting whether the door is yeah, it's detecting if the vent has closed or if it's open. So it's a detection circuit to determine if that vent is going to be open or closed. That's essentially what it would be for. But great questions that you're asking here. I love it. I love the participation. Any other questions from you or anybody else over here?
No, I'm
Okay.
okay. Thank you very much.
Awesome, awesome. Thanks for joining. So let's go ahead and now, again, no spin, no agitate. Now, we talked about earlier the fact that you have three major things that will drive obviously the basket to spin, right? It's your main, your inverter, and your motor. Now, we also mentioned the fact that the motor windings are about 3.5 ohms. And again, it depends on the model you're working on. It could be higher or lower, but in general, they all have to be equal, 3.5 ohms. So we also said earlier in the conversation that the main board supplies 120 volts AC, but I didn't tell you where, and here's where I'm going to show you, okay? Along with the 120 volts AC, there's also DC communication. So that blue double arrow, that means that there's communication going back and forth between the main and the inverter. And once the inverter receives the 120 AC and the signal to drive the motor, it is going to generate DC voltage to the motor. Now, this is voltage you cannot measure, okay? The only thing you can measure here, the only thing you have control of is the 120 volts going from the main to the inverter and the low voltage going from the main to the inverter in the DC signals. Okay, so keep those two in mind, and then it'll come back to us in a second. Now, the motor itself, as it's spinning, it is also going to generate a DC signal, and that is going to be your feedback. Okay, that's from the Hall sensor. That's going to be your feedback coming back to the inverter, which is basically going to be fed back to the main. So all in all, my friends, very simple. The main board provides 120 to the inverter. The inverter takes that 120 and makes it into DC voltage, variable DC, that drives the motor windings, motor spins. As the motor is spinning, it's sending a signal back, a feedback signal to tell the main board, hey, I'm spinning good, or no, I'm not spinning good, I'm stuck or something. So all this is important. You don't have control over that feedback signal, but what you do have control of is the 120 volts AC going to the main. And here's how, sorry, going from the main to the inverter. And here's how you can check it. So the connector is going to be J506. And if we, again, I like to zoom in case you're watching this on a cell phone. You notice this is a 5-pin connector. We kind of talked about what the connectors look like, with pin number 2 being your inverter neutral. So that's your neutral line. And pin number 3 is your switched AC. And the reason why it's switched is because, again, the voltage that goes from the main to the inverter is only going to be there if you actually want to drive the motor, either to spin or agitate. When the machine is dormant or it's draining or it's filling, there's no AC voltage going from the main to the inverter. Okay, so that's why it's switched voltage. And of course, pin 1 is your ground, because there always has to be ground anytime you have an AC line. Now, with that said, how are you going to measure that? Well, it's actually very simple. we're going to go ahead and take our multimeter leads and place them on that connector right there. Connector, what do we say, 506, right? So you're going to find the black, let me see, what is it? The black and white wires. That's your, black is your switch AC, and W, your white is your neutral. So you're going to find those, put your multimeter leads there. Then you're going to activate the spin action or agitate. And what you should see is the voltage going from 0 volts to 120 volts AC on your multimeter. Okay, so when the machine is not spinning or not agitating, 0 volts. Once you call for spin or agitation, 120 volts AC. And that is how you would determine if your main board, the initial part of the spinning action, is doing its job. If there's no switching there, then your problem is going to be your main. And this is what a lot of technicians miss. They don't, either because they don't know, nobody has trained them, or they just don't check it. They say, you know, I replaced the main, sorry, I replaced the inverter, replaced the motor, still no spinning. Try your main. I mean, at this point, you're just swapping out parts. But if you were to diagnose initially, then you would know it was your main all along. All right, so very, very important that we understand this concept. Any questions about this part before I move to the other thing that could cause this thing not to spin? Okay, so so let's say you do have voltage, right? And your motor windings are good. Well, that's about all you can check as far as your inverter board, okay? Now, there's another component we haven't talked about, and that is this bad boy right here, the accelerometer, okay? The accelerometer sits on top of the plastic like drum, right? If you open the top cover of the washer, the first thing you'll see attached to the top of the drum is going to be that piece right there, the accelerometer. And this is the component that basically detects when the machine goes out of balance, goes all wacky because maybe you didn't level the legs, or maybe the customer overloaded the washer, like things like that. And it's going to send the signal back to the main to tell it, whoa, we got to stop because this machine is way out of balance. You're going to destroy something in the house. So if this accelerometer is bad or disconnected or it's got no voltage going to it, guess what? No spinning action. And the good thing is that if it's the accelerometer, even before you do any troubleshooting, the fault code is gonna be listed when you go into the service mode. So that's another thing. You need to know how to get into service mode. Whether you do it using the tech sheet, it tells you what buttons to press, how to turn the jog dial, or using Smart HQ Service, you have to identify the fault codes first. That's a lesson for another class, but because this is schematics, but very important. Fault codes are extremely important for identifying if you have a bad accelerometer. So how can you check the accelerometer? Well, you can go ahead and check voltage from the main, which is J901, and then that voltage goes to the accelerometer, which is that one connector, J301. Obviously, the lines we're going to check for are your ground and your 5 volts, which in both cases, it happens to be pins 1 and 4, whether you're at the main or at the accelerometer. And what's nice is that because the accelerometer is at the top of the machine, you can actually, if you remove the cover from the machine, you can check the voltage at the main and at the accelerometer to make sure the wire harness is good. Obviously, if you're not getting voltage from the main control board to the accelerometer, then that's an indication that you have to replace the main board. If you are getting voltage from the main board to the accelerometer and you're still getting that fault, replace the accelerometer. But that would be another component that would cause a no spin, no agitate issue because, again, it has to detect if there's a problem with an out of balance condition, which I don't have to tell you. I've seen machines walk, especially when customers install their own machines and they leave the shipping bolts. You know all about that, right, Andy? It happens. It happens. All right. So, any questions, my friends, about anything I've talked about here? Feel free again to chime in or type your question in the chat. There's no wrong question here. While you're doing that, again, the schematic symbol here is a 4-pin connector, but in your world, it's going to look a little something like this, just like that. And look at that. That's kind of really nice because you could see on the schematic B, Y, N, R, and on the board itself, it's black, yellow, blue. Blue is N, I guess navy blue, and R is red, right? So it's very easy for you to identify these. Once you learn the schematic, it's super, super simple for you to know where to place your multimeter leads. And look at that, up top is that pressure sensor right there. All right. So that, my friends, would be pretty much everything in terms of troubleshooting that, or as far as what you have control over in terms of troubleshooting a no spin condition. But there's one thing we didn't talk about in this circuitry I just mentioned, right? We didn't talk about how do you troubleshoot the feedback signal, the RPMs. How do you troubleshoot that hall sensor, the signal that travels from the motor to the inverter all the way to the main? Well, the truth of it is there's no way unless you carry with you an oscilloscope. If you know what an oscilloscope is, it can give you square waves or sine waves. It's basically not something you use in the field. It's used in a lab. Nothing that we carry around, as a repair technician. But Smart HQ Service is going to allow you not only to activate these components, right, on demand with a single push of a button, but also you're going to be able to graph the data. In other words, understand the speed signal that's coming back to know if you have a good working machine or not. And you can use this to test the machine, or you can use this after you make your repairs to verify that the drum motor can get up to the highest RPMs, which I think it's like either 1100 or 1300 in a front load washer. I mean, that thing can get really fast, okay? So with that said, my friends, I want to go ahead and show you this quick clip over here of how Smart HQ Service can help you understand exactly what's going on without taking out a single tool. Take a look. Going to see right now is amazing. What I'm going to show you right now, my friends, is how you can run a spin test right from your application and essentially ramp up the speed on the motor and graph the speed, right? So we're going to see two things. We're going to see the target speed, but we're also going to see the actual basket spin speed. Spin action on. And now you're going to see that basket begin to spin, first slow, and then it's going to really get up there. Now, when you do this, my friends, do not do this with the door open, okay? I'm a trained professional in a controlled environment. So this tells you right now that the machine is capable of going up to 800 RPM at the very least. But as soon as it gets comfortable, all right, the stakes are going up. Whoa, look at that, 1100. What we just did right now, my friends, okay, is we were able to activate the spin test by utilizing Smart HQ Service and verify that the motor is capable of spinning the basket all the way up to the maximum target speed. That's extremely important because that's going to prevent your clothes from coming out wet, right? If the washing machine only spins at a low speed, it's not going to be able to squeeze the water out of those clothes, right? And they're going to come out wet. All right, my friends, so you just saw right now Smart HQ Service in action, and I just dropped a link in the chat for all of you to click on. So whenever you can, click on it, save it. That portion that you just saw is a very small part of a full training that we do on how to utilize Smart HQ Service to diagnose washing machines, but we also have training videos on other laundry product, the dryers, the dishwashers, fridges, wall ovens, the whole nine, right? And soon we're going to have something also on sealed system as well. So very important that you continue to learn, continue to educate yourself because there's a ton of information out there. But again, the use of Smart HQ Service in this particular case, two things I can think of right away. Number one, if you want to just go ahead and activate your spin or agitate without having to go to the user interface from Smart HQ Service, you can just go ahead and click the button. And if you have your multimeter leads on the board for that 120 AC coming from the main, you can turn it on and off on demand, right? And you can see, is it working? Yes or no. The other thing is, and probably the most important thing here is that RPM signal. Again, without Smart HQ Service, there's no way for you to measure it, right? Because you just don't have the tools to do that. But as you saw with the Smart HQ Service tool, you can actually measure the RPMs. You could see if the RPMs are getting to the target speed. And with the data graph, that gives you a nice visual view. And what else is, like, if you show this to your customer as you're repairing their product, they're going to be like, wow, this is pretty cool, pretty high tech stuff that you got going on here. It just gives you that extra level of credibility, right? And that goes a long way, right? One more thing I want to talk about before we leave over here, my friends, because we're pretty much heading toward the end of the presentation, is there's also some questions that I've come across where, and we actually had a gentleman ask this morning. He said, sometimes when I have a no drain condition, right? It's great that you showed me on the schematic how to measure resistance, how to measure voltage from the board, J512, how to trace the lines, all that good stuff. But he's like, sometimes I replace the main for a drain issue, and it still doesn't work. I replace the drain pump, it doesn't work. When I replace them both, now the drain pump works. Why is that? Well, there's a couple different things that could be happening here. Again, it's all about troubleshooting. But a lot of the times, there's going to be knowledge that GE Appliances provides to you that gives you more information than just going out there trying to troubleshoot it yourself. And what I'm talking about, I'm going to switch over here. What I'm talking about is if you go to the Smart HQ service, the the dashboard screen, there's a section called product features. Under there, it's manuals and bulletins. And take a look at this. In the recent bulletins by model, I'm going to go ahead and click on this training bulletin. This is available to anybody, right, that gets Smart HQ service. This is telling you how to troubleshoot a no drain condition on an ultra fresh washer. And to break it down, the bottom line is it's asking you to check the main control board for this transistor right here, Q553, for damage. Now, how does that damage happen? Is that damage as a result of the board being bad, or what's happening? So what it's telling you here, and again, I won't bore you with the reading, unless you maybe want to take a screenshot of this, but essentially it's telling you to run test number 12, which is a drain pump test, to verify that you have 120 volts AC. It's also telling you in step number 2, I kind of went backwards here, but it's telling you to check the resistance of the drain pump, which is 19.5 ohms. Now, step number 6, which is the most critical part, is saying if the main control board has a failed component, in other words, it's got that burn mark, verify the wire harness is not shorted to chassis. So you have to ohm out the wire harness and replace the drain pump first, then replace the main board. If you do this backwards, if you replace your main and there was some kind of a problem with the wire harness, you're going to fry that board over and over and over again. So check the harness, replace the drain, then replace the main control board. That's what's going to help you, with your troubleshooting. And that's why it's important to have these resources available to you, because, the tech sheet is great. It gives you lots of great information, but GE Appliances, we're constantly putting out information to make your job easier. You just need to have access to this information. Okay. And that's what we're here to provide. So that's pretty much the entirety of the course, my friends. I just want to say, really thank you so much for having taken the time out of your busy schedule to join us. A lot of this information, you can actually take it today. And if you have a washing machine service call, and apply it right away. Okay. I like to try to show things that are going to be of practical value, because if I'm taking a training, I want to be able to apply it as well. So hopefully this did that for you. And I'll open it up to any last minute questions that may be on the line.
I have a quick question, Juan. In the past, you've talked about servicers charging for software upgrades using the Smart HQ. Can you touch on that quickly?
Absolutely, Andy. So one of the biggest advantages of Smart HQ service, and we'll sort of go back over here. If you look at the dashboard screen, there is a function there called firmware update under diagnostics, right? So that firmware update gives technicians the ability to be able to resolve a software related issue without having to physically replace the board. All you have to do is flash it. So what a lot of service companies who have Smart HQ service have done is they've been able to increase their first time fix, because maybe you're walking into I'll give you an example, dishwasher that the user interface is dead. We actually have a software update that will fix that without you having to replace the UI, right? So here you are thinking, oh man, I'm gonna have to go in there, split the door halves, replace the UI, or take it out, order the part, have to come back. When in reality, you walk in, plug in, 5-10 minutes, you're done. The software update fixed the unit, and the customer is happy because you fixed it. Not only does this resolve the issue right away, but it also opens up capacity. Well, this has value to it. So if you ever come across a situation where you're fixing an appliance and you happen to notice that when you plug in Smart HQ, there's a firmware update available, you have every right to charge the customer. Say, Mr. or Mrs. Customer, I'm here to fix, I don't know, something else on your dishwasher, but I see there's a firmware update available. Would you like me to go ahead and do it? It'll be an extra $75, whatever, $50, whatever it is. Otherwise, I can come back, but I have to charge you a trip fee. Well, the customer knows what's best for them. They're going to have you do it right away. You made an extra $50, $75, and everybody's happy because the machine is up to the latest and greatest version with any issues resolved. So that's a great point you make, Andy. It's a great tool, great way to leverage that tool so that you can help your customers while at the same time become more profitable.
Any last questions from anybody? Speak openly. You're among friends.
Indeed,
All
my friends. All right, just want to
right.
say thank you everybody for joining. Again, the link for our other trainings are on the chat. But for now, Andy, Lisa, and everybody else at Encompass, thank you very much, and have a great rest of your day. We'll see you, everybody.
We appreciate it, Juan. Thank you. And again, our trainings, thank you all for attending. Our trainings are on in encompass.com. We've added a lot of factory stuff. Take a look and help yourself to it. And we appreciate you folks attending. Have a good day.
And there's that QR code if you want to take advantage of the Encompass offer.